Okay guys, today we're going to look at solving systems of equations using the elimination method. The ultimate goal of the elimination method is to get one of the a pair of the coefficients beside either the x's or the y's to be the same thing, so that you can add or subtract the equations so that one of the variables will cancel out, leaving you with one variable so that you can solve the equation. Sometimes you'll have to do some manipulations to the equations by multiplying everything in the equation by a factor and then adding it, but that can easily be done. So we're going to look today at how to do that. There's three types. The first type we're looking at here is one that we can simply add or subtract to get the answer. So if we look, we have the same number here for our y's. They're both 10. But if I add those together, I will get 10y plus 10y is 20y, so that won't work. So I need to subtract the two equations, which means that I need to subtract everything in one equation from the other. So let's come here and simply put a minus sign here. And now we're going to go from x minus 8x, and that would give me minus 7x. And then 10y minus 10y, those will cancel out. And then I've got 3 minus 10, which will give me negative 7. So now I have negative 7x is equal to negative 7. So we'll divide both sides by this negative 7 and get x is equal to 1. Now that I have this x is equal to 1, I can take that and substitute it into either the first equation here or the second equation and get my answer. I'm going to use the first equation. This will give me 1 plus 10y is equal to 3. Then I will solve this equation, subtract 1 from each side. You'll get 10y is equal to 2. Divide both sides by the 10. And you'll get y is equal to 1/5. Or if you use your calculator or want to make it a decimal, you will get 0.2. So if you want to write that as an ordered pair, I would probably write it as 1, 1/5. Or you can put the 0.2 in there if you want it as a decimal. So let's look at the second type of systems of equations using elimination. In this type, automatically we don't see anything that's going to cancel out. The coefficients of the x are not the same, the coefficients of y are not the same. So we need to do something so that we'll get those coefficients the same. If I look at the coefficients of x, I've got an understood 1 here and a 2 here. So the least common multiple between those would be 2. If I look at the coefficients of y, I've got 3 and 2. The least common multiple of those would be 6. So I think it will be easier to solve for y here by canceling the x's out, because I can do that using one step. So I'm going to come here and I'm going to multiply the second equation by 2 so that I will get the same number for my x's in the first equation and the second equation. I'm going to simply just copy down the first equation. 2x plus 3y is equal to 6. And now I'm going to come through and I'm going to multiply 2 times everything in the second equation. So 2 times x would be 2x. 2 times 2y would be 4y. And then 2 times 5 would equal 10. Now that we got that, it's kind of like the first problem. We've got the 2's are the same here. But if I add those together, I will get 4x. So I'm going to need to subtract these two equations. So I'll take my 2x minus 2x. Those will cancel. Then I got 3y minus 4y will give me negative 1y, which we'll write as negative y. And then 6 minus 10 will give me negative 4. So I got negative y is equal to negative 4. We'll divide by negative 1 to solve for y, and y equals positive 4. Now I'm going to take that y equals positive 4, and I think I'll substitute it into the second equation here. So I'll have x plus 2 times negative 4 is equal to 5. So I get x plus negative 8, which we can just leave as x minus 8, is equal to 5. So then x, to solve for x, we need to add 5 to each, or add 8 to each side, and x will equal 13. So if I'm going to write my ordered pair, that would be 13, 4. So this is the second type system equation, where we can use one step to solve to get one of our coefficients to cancel out. The third type that we'll look at is where we'll have to multiply both equations by something to get a cancellation. So we got 3x minus 2y is equal to negative 7, and 2x minus 5y is equal to 10. The least common multiple of the coefficients of my x, 2 and 3, would be 6. The least common multiple for my coefficients of y, 2 and 5, is going to be 10. So I can cancel either one of those fairly easy, but I'm going to have to multiply either one of those, or both equations, by something to get that to happen. I'm going to go ahead and just cancel out the x's here. So my least common multiple is 6. So I have to think, what have I got to do to 3 to make it 6? And that's multiplied by 2. And what have I got to do to 2 to make it 6? And that is multiplied by 3. So I'm going to multiply everything in the first equation here by 2, everything in the second equation here by 3. 2 times 3x is 6x. 2 times 2y is 4y. And 2 times negative 7 is negative 14. Then I take your 3, multiply times everything in the second equation. 3 times 2x is 6x. 3 times negative 5y is negative 15y. And 3 times 10 is 30. Now I'm going to change all the signs again, or subtract the two equations, so that they will cancel out. So let's subtract these. 6x minus 6x, these will cancel. Negative 4y minus negative 15y. If you need to, you can write that out over on the side. You can work that out, or if you need to use your calculator, that's fine also. But as you can see, this will become plus a positive here, and we'll get positive 11y here. And then negative 14 minus 30 will give us negative 44. Then we'll divide by 11 to solve for y, and y is going to equal negative 4. Now again, now that we've got what one of our variables equals to, we'll take that, substitute it into one of the equations to solve for the other. I'm going to substitute it into the second equation. So when I do that, I have 2x minus 5, parentheses, negative 4, close our parentheses, equals 10. So I'll have then 2x negative 5 times negative 4 is positive 20, is equal to 10. Subtract 20 from each side. And I'll have 2x is equal to negative 10 divided by 2. X equals negative 5. So our order pair for this one would be negative 5, negative 4.